In this video, we're going to be taking a look at 10 different ways in which you can search a patient resource. There is also another extra bonus one, and it's quite crazy. We'll go at it in the end. So the first way is obviously if you have a patient identifier, you can just search with this identifier. Here, this is 123, and we see there are 2 patients in this system with 123. Now, again, that's not ideal, but this is a test server that we use for our FHIR bootcamp students, and many of them decided to have a patient with the ID 123 and 1234. So this is, again, an exact match for this particular 123. So if you try something like 12, this will not match, right? And the reason is because identifiers in FHIR are treated as tokens. So it's either an exact match or you don't get anything at all. That's something to keep in mind. The next way is you can actually have multiple identifiers, and if you add a comma, then it will OR these identifiers. So this is any patients with the identifier of either 1234 or 123. And in this, again, we actually get back 3 patients this time because I think there is another additional patient with patient like this 123, 1234. There is 123, and there is another patient with just 1234. Okay, so it will match both of this. Now, this, again, the comma actually ANDs this, but it's also important to note that this is a behavior that's determined by the server. So for example, if you have a search parameter and you have an implementation guide, and here we are on the US core implementation guide, they teach you how this multiple is supposed to work. So again, the multiple ORs, this is what we are doing right now. It's up to the server whether the parameter can have multiple values separated by comma, where at least one must be true. So again, it needs to support at least one, but then it's up to the server if it really supports ORing multiple identifiers, and so that's something you need to know. Now, this is the AND. This is unique. If you want to search for patients with, for example, identifier of 123 and 1234, then you just do identifier equals this and identifier equals that. So let's try this out. And we see that we only get back 1 patient who actually has both 123 and 1234. So quite simple, but again, this is also determined by the multiple AND section of a particular search parameter. So do check the implementation guide and see how it's to be handled. Sometimes they just say it's up to the server. You don't need to implement this, but sometimes they actually mandate it and say that you need to support multiple ANDs and multiple ORs. So that's the AND. Next, let's take a look at how you can search by exact name, right? Usually this the name equals something that's quite common. It does it in terms of a particular, anything that contains this will work. But let's actually do the exact. And now you see that only patients who have Volk in their name exactly. So in this case, this patient's name is Alex. It's actually Volk Alex. And we have another patient here again, like Volk Alex. So we have 2 Volk Alexes. Now, something to note is that you can actually do a partial match with just name. And this, again, this gives us 3 patients. So you have Volk Alex. You have, again, Volk Alex. Oh, sorry. Where is the 3? I think this is, that is 1. Yeah. So we also have Nikola Volkov, right? And in FHIR, name is a string. So when it matches with a string, it doesn't really consider multiple, it doesn't consider the exact match. It can just start with Volk and that will still work. And in this case, if you add this additional modifier that says exact, then it will only match something that says exactly Volk, and it needs to even match the casing and the character. So if you do something like Volk, all lowercase, you won't get anything, right? Because the exact is completely case sensitive. But you can do the same thing with just name, and it will again return all 3 because this is not case sensitive. Up next, what if you want Vol or something like Volk, but then it can be present anywhere in the name. It doesn't need to be starting with VOL. So that's where you do contains. So in this case, you do name contains Vol, and then we'll take a look at an example, and we have 3 patients that match. We have Volkov, we have Alex Volk,
And again, here we have Volk Alex, but I think this is not a good example. So let's quickly just create a patient, because the contains is actually, it will match even if you have it in the middle, right? So let's actually do the name as Olo Volk, right? So this does not have Volk as a name itself. It doesn't start with Olo Volk King. I don't know if that's a name, but let's just say that this person called Olo Walking comes in, and we are, posting this patient. And what we can do here is we can go to name contains, and now we should technically see 4 show up here. Let's try that. And we see 3, because again, this is another thing to note in while searching, especially with FHIR. It takes a while before your results show up in the search. So it sometimes can take up to a minute. And a way that you can avoid this is, again, like there is a happy search caching. You can just say no cache. There is a particular header that you can use for this. Again, this is the query params. You can go to the header section, and you can say cache control, and you can say no store. And this will actually help with that. So let's quickly look at the configuration. Again, by default, it sets it as 1 minute, but you can absolutely just add a particular header. You can just say cache control, no cache, and this is what we are going to do now. No cache. And now we should see the 4th patient. And in this case, this is the name contains. And we also have, we have Volkov Nicola, we have Volk Alex, and we also have the same one again, and then we have whatever this name is. But then it contains Volk in the middle. And that's how this works. And this is also case insensitive, so you can have all caps and it'll still match. Okay. The next one is, what if you want a range of something? And this is where the greater than and lesser than sign comes in. And again, I'll show you that there are actually a lot more of these operators. There is like equal to, not equal to, this contains, starts with. All of this can be applied on most search parameters in FHIR that are like numbers. So in this case, you want to look at all patients who have a birth date that is greater than or equal to. Again, GE stands for greater than or equal to. So again, there is equal to, there is GE, GT is greater than, and GE is greater than or equal to. And here we have LE, which is again lesser than or equal to. So we are looking for all birth dates in this particular range, and we actually get 4 patients, all of whom have birth dates that are within that particular range. It's pretty straightforward. But did you know that you can also like search for missing values? So you can actually say, okay, I want to look at all patients whose telecom is missing, like all the patients without a phone number. And let's try that. And we see that we get a lot of patients actually. So we are actually limiting the results here, but none of these patients have telephone numbers. And this is just part of one of the modifiers that are allowed in FHIR. There is also like above, below, contains, exact. And again, we used contains, we used exact before, but missing is just another type of a modifier. And there are a lot of these. So there is not in, and so on. So you can just read this up if you really want to check all the possibilities. And again, we have a free course on this as well. We'll leave a link to that down below. You can just check out all the different search parameters on FHIR. And it's again, like it's completely free. We just want you to be able to use FHIR well in your particular use case, right? So do check that link down below if you are interested in that. Now moving on. So you have, this is called like chaining of multiple search parameters. So what we are doing here is we are saying we want all patients whose general practitioner's name is Caleb, right? So we are not even saying the general practitioner should be a particular ID. We are searching on the general practitioner whose name is Caleb, and then the patients who have that we want to like return, right? So in this case, we see that, okay, we have 4 patients, and the first patient, we can see that the general practitioner is actually a reference to this other practitioner resource. But if we actually, let's create a new request under this collection. Okay, let's create a new request. And let's just use the same URL. And then in this case, we are going to say practitioner/particular ID. And then if we get that, we see that the name of this practitioner is actually Caleb, right? So we did a chaining of a search, and that's pretty cool because you can do this on all fields in FHIR servers that support it. And that way you can actually even get like really complex relationships, and you can get the practitioner whose name is Caleb, and you can get that patients who have this particular practitioner. There is also another cool way to do search in FHIR, which is using the has operator. This is also called reverse chaining. And in this case, what you say is, I want all patients who have an observation with this patient where the observations code is test 777. Right? Like again, we are just testing in here. But this could be very cool where you say something like, I want to list all the patients in my system whose blood pressure is more than 120, right? Show me all the hypertensives in my cohort. It could be very useful for something like that. In this case, we just got back the patient, right? We got back this patient, but then we know that there is some observation code that this patient has that is 777, like test 777. You can also have more complex checks here, but again, like you can do all sorts of crazy stuff. Now, in this case, it's not very evident what this actual observation that got us this particular result is. And in a search, it would actually be good to include this as well. And that is where the includes come in. So for example, includes and rev includes is really useful in this case. So for example, if we say, okay, we actually want a patient with the exact match of Maya, and we also want to retrieve the general practitioner of this patient, right? You'll not only get the entry which says patient. Okay, let's don't save this. Let's just do this again. So you get the entry, and then you say that, okay, this is the patient, this is yada yada, but you also get a practitioner resource along with it. And this practitioner, again, it doesn't say that this is not a search match. This is actually just an include, right? So you'll get all of this, and note that the total under the search set does not reflect the includes. It usually will not include the thing that you're asking to bring along with. So this patient, again, we know that this particular patient has a general practitioner, and this general practitioner's name is Caleb, right? So it will be really cool to even combine multiple of these. What if you say, okay, I don't want to say name exact as Maya, but then I want to search by the chain, right? What if I want to say, I want a general practitioner whose name is Caleb, but then also include this in the search result when you do the search, right? So that way you can confirm that, okay, this is actually indeed Caleb. And in case we are seeing 4 patients, and for all of these patients, the general practitioner is this particular thing, and it smartly knows that it's only one. So what it does is that after all of the 4 patients, we then have the practitioner resource here under Caleb. So notice that the FHIR server didn't return this 4 separate times. Like it just returned it once after all of the patients. And you can just know that by the reference, right? Like there is a full URL here, and that same full URL is always referenced under practitioner. So that's pretty cool. So what if you want to do the other way around? What if you have an observation and you want to include that particular observation which matched, right? We did this previously. So in this case, we say, okay, what if you want exact match of Maya, and then you want to also include all of the encounters that Maya is part of, right? So in this case, you can just do that. You can say rev includes encounter : subject. Just notice the syntax. This is usually also the search parameter name in encounter, but then you should just use the colon instead of a dot. I know it's a little confusing, but once you get used to it, it's quite easy. So in here you get the patient. Again, this patient is Maya, but along with that you get the encounter resource that's associated with this patient. And here we see that the subject is indeed referencing back to patient. This is also very useful when you're using it with the has. So let's say we want to see all of the so let's actually do that in here. So let's say we want to actually query by patients who have this observation code of test 777, but then we want to also reverse include the observation subject, right? So this will actually give us not only this patient, right? We got the patient. Let's minimize this, but it will also give us the observations that belong to this patient. And again, this is the test code 777 that we actually queried for in the first place. So super useful when you are chaining different things and like making it work for a complex application. And finally, we'll also look at payload limiting. I know we are already over the 10 limit, but the last one is like quite crazy. So you'll like just listen to that as well. This one actually limits what you get back. So let's say you have underscore elements and then you just want the name, date of birth. You'll only get the name and date of birth back from the patient. So in this case, we got this particular patient and there is the date of birth and the name. But if you actually remove this completely, then you'll get the same patient and you get like telecom, you get gender and so on. So if you want to redact information and you don't want to show more than what is required and you just want access to certain elements, then you can just say underscore elements and it'll only bring those fields from that particular FHIR resource. And finally, the last one, again, this is a bonus, but this is the filter parameter. And this is crazy. Like to me, this is like so powerful. You can almost do anything with it. So this is a new spec. Again, the FHIR working group has been working on this, but basically you can say patient name co-pet. That means that all patients with a character pet in a given name or family name. You can say given equal to Peter and birth date greater than this particular thing. So all that we've learned so far, whatever we have been chaining, all of this can be implemented through just a particular string, and then you can use the underscore filter search parameter to make all of this happen. So here we are saying the family should contain John and the gender should equal male and the birth date should be greater than or equal to 2017, right? Let's try this out. And it's insane, but then it actually brought back 2 patients who have all of these particular criteria met, right? So we have name of John, we have, the gender is male, and we also see that the birth date is somewhere in the future. So this is a test patient, so we don't really care, but this person is at least from 2017. So very young John, I see. So hopefully that helped you understand a bit more about FHIR search. And if you really want the full course, there is a free course on all of the basics that you need to understand about FHIR. Do check that out in the description below. And again, thanks for watching. I'll see you in the next one.